Hi everyone, welcome back. Today we're going to be looking at standard 6.sp.b.4 and standard 6.sp.b.5. We're going to be focusing on box and whiskers plot. A box and whisker plot, also called a box plot, displays the 5-number summary of a set of data. The 5-number summary is the minimum, first quartile, median, third quartile, and maximum. The minimum is the least value in a data set, and the maximum is the greatest value in the data set. The median, also called Q2, is the middle of a sorted list of numbers after they have been placed in order from least to greatest. The lower quartile, or Q1, is the median of the lower half of a data set. This is after you found the median, the Q2, the data is split in two. The upper quartile is the median of the upper half of the dataset. The interquartile range is the difference between the upper quartile and the lower quartile, Q3 minus Q1. And this is not to be confused with range, which is the difference between the highest and the lowest number. So here is an image of our box and whiskers plot. If you notice, Q1 is represented here in the middle, and this is the median of the entire data set. Okay. Now, the lower quartile is the lower portion, and the upper quartile is the upper half. So after you find the median, it splits the data in half, and you'll see that in our next example. Our highest value is the same thing as our maximum, and our lowest value is the same thing as our minimum. Now, when we break up our data, we find that you have 25% of the data represented between the minimum and Q1, another 25% between Q1 and Q2, and another 25% between Q2 and Q3, and 25% between Q3 and the maximum. Okay, now we know 25%, percent is out of 100, simplified is 1/4. So that also means that I have 1/4 of the data between minimum and Q1, another 1/4 here, 1/4 here, and 1/4 here. So let's go ahead and try an example of our own. Step 1 is to list numbers from least to greatest. So if I'm working with the set 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I'm going to find my 5-number summary, which is my minimum, maximum, Q1, Q2, and Q3. So to find the median of my data set, I first need to identify how many numbers I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So when I split this in half, the number in the 5th position will be the middle value. So if I go from either side and cut off the numbers, then I will get to my median of 6. So this is our Q2, or our median. Now the lower portion of the data consists of 2, 3, 4, and 5, and the upper set consists of 7, 8, 9, and 10. I've already used my 6, so that will not be a part of either portion. So the median for the lower portion will be the average of 3 and 4, which will be 3.5. And this here is my Q1. And the median for the upper portion will be the average of 8 and 9, which will be 8.5. And this is my Q3. My min is 2. And my maximum is 10. So now I want to construct my box and whiskers plot on my number line. I'm going to skip lines just because I have some numbers that are halves and I want to make sure I accommodate that. So to graph the box and whiskers, we're going to use those 5 values, and in each of those numbers, we're going to just put a line. So my minimum is 2, so I put a line there. My Q1 is 3.5, so I put a line there. My Q2 is 6. I'm going to put a line on 6. My Q3 is 8.5, so I'm going to put a line between 8 and 9. And then my max is 10. To create the box, I'm going to combine the 3 lines in the middle. And then for my whiskers, I'm going to use them to connect my maximum and my minimum. So here I have my minimum, my Q1, Q2, Q3, and my maximum. And again, there's 25% of the data represented in each of these sections. All right, let's go ahead and try one more example. This is a good place to pause the video and try this one on your own. So I'm going to go ahead and place my numbers in order from least to greatest. Now we're going to find our median. So let's go ahead and find the median of the data set. Okay, so our median is 13. This is our Q2. And here we have 5 numbers on the other side, on the lower side. So the Q1 is 6 and the Q3 is 20. So let's go ahead and plug those in. So Q1 is 6, Q2 is 13, and Q3 is 20. Our minimum value is 3, and our maximum is 24. Now let's go ahead and construct our box and whiskers plot. So we put a line on 3, a line on 6, a line on 13, a line on 20, and a line on 24. We're going to use the 3 inside lines to construct our box. Sorry, my drawing is not perfect. And then we're going to use the whiskers to connect to the maximum and to the minimum. So here we've created our box and whiskers, and we can label min, Q1, Q2, Q3, and our maximum. So the question says, what is the range and what is the interquartile range? So the range is the difference between the highest and lowest numbers. So that would be 24 minus 3. So our range would be 21. And our interquartile range would be the difference between Q3, which is 20, and Q1, which is 6. So our interquartile range is 14. So now we're going to look at some examples from iExcel. This video is a little bit on the longer side, but bear with me if you are trying to master the wonderful problems that iExcel offers. Angie babysits to earn extra spending money. She recorded how much money she earned each time she babysat for a year. What is the range of the amount of money Angie earned babysitting? So again, the range is our max minus our min. And our max here based on the graph is at 60. And our minimum is at 15. So here the range is 45. Dougie's Donuts tracked the number of donuts each customer ordered for a few weeks. What was the interquartile range of the number of donuts ordered? So interquartile range will need us to use Q3 and Q1. So Q3 minus Q1, that gives us 12 minus 4, which is 8. So the interquartile range here is 8. For a month, Mrs. McCoy's science class recorded a low temperature each day. What was the upper quartile of the temperatures? So here we have Q1, Q2, Q3. So this here is our upper quartile. So the upper quartile is 56. Zach's step counter tracked how many steps he took each day for a week. What was Zach's median number of steps? So remember, our median is the same as our Q2. So Q1 is here, Q2 is here, Q3 is here. So the Q2 is located at 8,000. So that would be 8,000 steps. The coach of Darnell's baseball team recorded how many runs the team scored in each game. In what fraction of their games did Darnell's team score 2 or more runs? So each portion is represented by a quarter. 2 or more would be from here onwards. So we have 1/4 plus 1/4 plus 1/4. So that would be 3/4. Last year, Greg got a new job managing the gift shop at the Burn Valley Zoo. One of his responsibilities was to track the shop's total sales each day. This box plot shows the result. What percent of the time did the gift shop have sales of $3.50 or less? So again, each of these represent 25%. $3.50 or less would be here. So 25 plus 25 plus 25 would be 75%. Last summer, Maya was a lifeguard at the Ginger Hill Community Pool. She checked the temperature of the pool each morning. This box plot shows the result. What percent of the mornings was the pool temperature 80 degrees or higher? So 80 or higher represented here. We have 2 sections. So that would be 50%. In her free time, Isabel likes to read. She kept track of the number of pages in each book she read last summer. This box plot shows the result. What fraction of the books had 200 or fewer pages? So we have again 2 sections. Okay, and those are 25, which would be a quarter. So what fraction? So 1/4 plus 1/4 is 2/4, which can be simplified to 1/2. Emmett's party supply store is known for their long-lasting helium balloons. Emmett kept track of the number of balloons in each order he received yesterday. Which box plot represents the data? So in order to do this, we first have to construct our own. So let's go ahead and list the numbers from least to greatest. When I rewrite my numbers, I like to count them just to make sure that I have the correct numbers. So I have 10 in the original data set, and I also have 10 in mine. So now I'm going to go ahead and find my median. Okay, so we're just going to go from each side. And I find that I have 2 numbers in the middle. The average of those 2 numbers is 40. Now, when you have an even set of numbers and you find the average, the median, you do have to split that, and that number is now part of the lower set, and this number is part of the upper set. So I'm going to be working with 20, 25, 30, 35, and 40. I'll say that again. If I have an even set of numbers where I have to find the average of the 2 center numbers, then those 2 numbers go back into the data set and become a part of the lower values and the upper values. Okay, so instead of having 4 numbers here, I'm going to have 5 numbers because this 40 is going to join the lower and this 40 is going to join the upper. So my Q1, okay, I have 1, 2, 3, 4, 5 numbers, will be 30. This here was my Q2. And then my Q3 will be 60. So based on that, let's see which one of these graphs match. So they both have the same minimum. They both have the same maximum. They both have the Q2 as 40. Now let's take a look at our Q1, which would be 30. Okay, they both have that. And our Q3 needs to be 60, which would be the second graph. So that one would be the correct answer. The Brinklin Bakery is a popular spot for sweets. The owner tested 2 new brownie recipes by asking customers to rate some samples. These box plots show the results. Which brownie had the higher median rating? So we go ahead and identify the medians. So I have a median here of 8 and a median here of 6. So the choco chili would be the one with the higher median value of 8. Celine is training to run a marathon. During her training, she kept track of how much time she spent running on the treadmill, inside and on a trail outside each week. These box plots show the result. Where was there more variation in the amount of time Celine spent running? And we have this little hint here. You can use interquartile range to calculate variation. So let's go ahead and find the interquartile range for each of these values. So for the inside, we have 125 and 50. So 125 minus 50 is 75. And then we have 175 and 75. 175 minus 75 is 100. So the outside would have more variation. Let's take a look at one more example. To earn extra spending money, Tim does yard work for his neighbors. In the summer, he mows lawns. In the winter, he shovels snow. Last year, he kept track of how much money he earned each month during these jobs. These box plots show the results. Which job had more variation in earnings? Okay, so again, we're working with our interquartile range, which is our Q3 and our Q1. So for the mowing, we have 80 minus 20, which would be equal to 60. And for shoveling, we have 100 minus 20, which would be 80. So the shoveling would have the greater variation. Thank you for watching and have a great day.